So here we go. We talk about the challenge. Hopefully you have a solution. And really, this is all about thinking about those three dimensions: the length, the width, and the height, in order to multiply using the commutability property and get 24 as being your volume. And thinking about height, I'm not somebody, of course, blessed with a lot of height. That's probably why I spend most of my time climbing up. So my first step with this problem would clearly be to be thinking about how I can move those three dimensions: length, width, and height, in order to change the volume. So I'm going to need to find all of the possible factors of 24 and then move around those three dimensions. And by doing that, by moving all those factors around the three dimensions, we're going to be able to find all of the possible different combinations for our boxes. So we've been out here. This is my fingerboard, my pagoda in the garden. Time to head on back down to the Hunker Bunker, I guess, and we'll solve up there. But for now, we shall close.
As discussed outside, first really important task.
Kirsty's coming to look what's going on here, so you might have to take a photos. Oh, nice Kate.
And that was a button. So I've got my factors of 24. These are all going to be able to make a box. For each of these boxes, for example, 8 times 3 is going to give me 24. So now I'm going to multiply it by 1. But I can also think about how some of these factors might play into other boxes. For example, other ways where I could have 1 not be a part of this. If I take 8 and 3, 12 and 2, 6 and 4, they're all going to need to have 1. Now my next step is to think about the boxes such as 2 times 4 times 3. Where I've now factored down 8. For 6 I could have 3 times 2, which is times 4. Once I found my factors of 24, this is a matter of rearranging them to think about different boxes. Right here I have 2 by 6 by 2. If I take that same box and just merely twist it through 90 degrees, I now have 6 by 2 by 2. Both are going to equal 24. But if I now switch the order again, I'm going to end up with a totally different box. Because I'm not measuring, my 2 by 2 by 6 box ends up looking a little bit longer than it probably should. But we can see that we've taken the same basic box. Here we've turned it through 90 degrees, and here we've flipped it on one edge to get essentially the same box, but in 3 different orders of those numbers. So now I've listed out I've taken some factors, 12, 2, and 1. 12 times 2 is 24, 24 times 1 is 24. That law of commutability allows me to move them around and change the length, the position of each number to cycle it in and out of length position, the width position, and the height position. And I end up with 6 possible boxes as I look at them. But notice now that I have a factor grouping where I only have 2 different numbers, 2 times 2 times 6, so 2 times 2 is 4, 6 times 6 is 24. I now have 2 different numbers, but I've halved the possible boxes to 3, because whichever way I switch this around, it's the same box. And similarly, here I only have 1 option to go into my height. So we've got 3 possible boxes. So this gives us 30 possible boxes using all of these combinations. Now, of course, what would change this is if I now allowed myself to have fractional side lengths. If I have fractional side lengths, I could have a box that is 12 times a half times 4, because it's are going to give me 12 times a half is 6, and 6 times 4 is 24. The important idea here is, though, that we have the law of commutability allowing us to move the numbers around, and that our formula is length times width times height. If we add fractional sides, we would get a far greater number of possible boxes. But this is a good exercise in factorization and thinking about depth and how we change that box around. I'll linger one last second to see if you can pause this maybe and see if you got all of them. If you have any that you think I've missed, email me, let me know. I'm not infallible. All right, have a great day.
Well,